Okay, let's jump right in. For today's deep dive, we're tracking a really fascinating story.
Mhm.
It's the story of where human intuition, our knack for patterns, just completely falls apart.
And where silicon intuition AI starts to take over, we've seen so much of that in 2024 and 2025.
And we have the perfect starting point. It's an integer sequence, miniature 19 plus 192, SOCODOT 209.
It looks so innocent.
It really does. I mean, you plug in the first few numbers, and out of the first 8 results, 5 of them are prime numbers.
Which is a huge density. Your pattern-seeking brain just lights up. You think you've found something fundamental.
But you're saying it's a trap.
It's a total trap. The
Yeah.
sequence is engineered to look convincing right before it fails spectacularly. That pattern is completely spurious.
So what happens? Where does it break?
It breaks at n equals 7, but it's how it breaks that matters. It's not just bad luck.
Okay.
At n equals 7, you get the number 24,257. And that number is specifically chosen so it factors perfectly.
Into what?
Into 127 times 191. And that 127, that's the absolute value of the very first term in the sequence. The trap was set from the beginning.
Wow. Okay, so we fall for this kind of thing all the time. Why?
Well, it's because of what the mathematician Richard K. Guy called the strong law of small numbers.
The strong law of small numbers.
Yeah, the basic idea is just that there aren't enough small numbers to go around, so, a few of them will accidentally line up and create all sorts of patterns that don't actually mean anything.
Oh, this is like Moser's circle problem, isn't it? The one that drives everyone crazy.
Exactly. It's the most famous example. You connect points on a circle.
We account the regions.
Yeah.
And it goes 1, 2, 4, 8, 16.
You feel like a genius. It has to be powers of 2.
And then you connect 6 points and you get 31.
31. The whole pattern shatters. The real formula is way more complex.
But some patterns are real, like Euler's polynomial, $2 plus n plus 4u on one other one.
Now that one is the real deal. It spits out 40 primes in a row. And what's amazing is that we've proven it's the best possible.
The best possible.
For a simple formula like that, yes, there's a hard theoretical ceiling. Human curiosity basically pushed simple algebra to its absolute limit there.
So if humans hit a wall, that's where the AI comes in.
Yeah.
This is the shift to what you call industrial scale discovery.
Right. And the AI doesn't think like we do. It ignores the surface level patterns.
Yeah.
Take the Ramanujan machine.
What did it do differently?
Instead of just checking numbers, it looked for high-dimensional structure. It found something called conservative matrix fields, or CMFs.
Okay, CMFs. And these are what?
Think of them as unified maps that connect totally separate constants, like pi and others, that we never thought were related. The AI finds connections that we can't visualize.
And then there was DeepMind's Fun Search.
Yes. If the Ramanujan machine showed us what AI could find, FunSearch showed us how. It solved the really hard CAPSET problem.
Right, by using a large language model as a sort of creativity engine.
A mutation engine, yeah. The LLM suggests little bits of code, and a sandboxed evaluator tests them millions of times. It's like evolution for programs. And it found a solution with symmetries humans had just completely missed.
But how do you know the AI isn't just making a mistake? A hallucination.
Ah, that's where alpha proof came in. Mid-2024, it paired an AI with a tool called Lean.
Wait, what's Lean? Is that like a spell checker for math?
That is a perfect analogy. Lean is a formal proof assistant. The AI can suggest the steps, but Lean checks every single logical link against the axioms of math.
So no hallucinations allowed.
None. It guarantees the proof is 100% correct. It was solving International Math Olympiad problems with that.
It feels like we're crossing a threshold. The Fields medalist Terence Tao said mathematics is moving from an artisanal phase
To an industrial one.
Yeah.
Exactly. We're going from handwritten proofs to AI-formalized, factory-produced mathematics.
which brings us to this new challenge, what some are calling alien math.
Yes. The AI is finding things like those CMF structures that are provably correct, but that we have no way to picture, no physical analogy for.
So our job changes. We're not just finding the patterns anymore.
Our job becomes interpreting the machine's logic. We're trying to understand a mind that is fundamentally alien to ours.
Which leaves a pretty profound final thought.
It really does. If AI can find mathematical truths that our brains can't even grasp, what fundamental truths about the universe are hiding right there, in plain sight, just waiting for a different kind of mind to point them out?